So chapter 7, Introduction to Polynomials. So this first lesson is going to lay the groundwork. So there's a lot of definitions and, like I said, just some groundwork that we're going to need to be able to do the rest of this unit. So it says the way we write numbers in our number system is interesting because we only have 10 digits, all right? So base 10, all right, is what we work with. We're able to write whole numbers that are as large as we would like. This is because what we really are doing is counting how many powers of 10 that we have. And that's pretty cool. So let's delve into that a little bit. A little number theory going on here, which is awesome. It says, write each of the following numbers as a sum of multiples of powers of 10. Okay, so what do I mean by a power of 10? Okay, 10 to the 0 power, 10 to the first power, 10 to the second power. Those are powers of 10. So it says this 563 is done for us. So 563 means, if we think about place value, 500 plus 60 tens plus 3 ones. So if I further sort of expand that out, it's 5 times 100 plus 6 times 10 plus 3. Okay, we have 5 hundreds, 6 tens, and 3. Essentially, we could put a 1 on the end there, 3 ones. So now as powers of 10, 100 is just 10 squared. So this is 5 times 10 squared plus 6 times 10 plus 3. And technically, again, we could put this, is we could put 10 to the 0 on the end of that. Okay? So let's jump over to letter C, because we have 3,842. So let's think about what that means. 3,000 plus 800 plus 42. All right? So now when we think about that a little bit further, it means we have 3 thousands. Okay? 3 thousands. 1,000 plus 1,000 plus 1,000 plus 8 hundreds plus, I'm going to shrink this a little bit so we have a little bit more space. Oh, fingers. Can't do that. All right, bear with me on this. Okay. Plus 4 tens, and then plus 2. Okay, or 2 times 10 to the 0 power, but we understand that we don't need to write that. So now as a power of 10, okay, we end up with 3 times 10 to the third. Because 10 to the third is 1,000. This is going someplace, honest. Like I said, we're leading up to the polynomials. So we're playing with numbers that we're familiar with in place value and powers of 10. Plus 8 times 10 to the second, plus 4 times 10 to the first, plus that 2. Okay? And again, you could put on the end 2 times 10 to the 0 power. All right? But we don't need to do that. All right? So let's see. It says we can now use algebra, okay, to replace the base of 10 with the generic base of x. Okay? There's our famous letter, or whatever variable you like. So it says, consider the number 63,735. As at number 1, write this number as the sum of multiples of powers of 10. So we have 60,000. 60,000. Then we have 3,000. Okay, because that gives us the 63,000. Plus 700 plus 30 plus 5. So now let's break that down into powers of 10. So I'm going to kind of skip a step here, and I'm going to say 6 times 10 to the what power? That's 10 to the 4th power, right? 10 to the 4th power is that 10,000. And then we have plus 3 times 10 to the 3rd power, because 10 to the 3rd power is 1,000, and we have 3 of those. Plus 7 times 10 squared, because we have 7 hundreds. Plus plus 3 times 10 to the 1st, plus 5. Okay? So now it says, if x equals 10, write this number in terms of an equivalent expression. Okay, so an expression, no equal sign, involving x. So essentially what we're going to do is we're going to put the x in place of the 10. Okay? So now what we have, this is what we are replacing. Okay, we're replacing that 10 with an x. Let's rewrite, and we'd say, let's change colors here, 6x to the 4th plus 3x to the 3rd plus 7x squared plus 3x plus 5. Okay, so now we've taken something that we're very familiar with, okay, just a basic number, and we've talked about place value, and now we're extending that to algebra to bring in the idea of polynomials. So if you can keep in mind, when you add or subtract numbers, you have to add and subtract I just lost what I was looking for. Like place values, sorry about that. And you line up place values. So essentially you're combining place values when you're adding or subtracting. Well, that's exactly what we need to do with polynomials, is we're going to add and subtract like terms, which think about it in terms of like place values. Okay? So what is a polynomial? It says the base of a polynomial certainly doesn't have to be 10, but all polynomials have a form similar to your answer in letter B. Okay, so let's define them a little bit more definitely. So a polynomial expression, okay, what makes something, okay, so let's break down that word, okay, poly meaning many, expression, no equal sign. So an expression of the form, okay, so this is our in general form, where the exponents are n minus 1, n minus 2, meaning they're decreasing from left to right. It says are all positive integers. Okay, that's important. They're positive integers. Note, not all powers need to be present because the coefficients, okay, a, b, and c, can be 0. Okay, so meaning it doesn't have to decrease in chronological order in the sense of, like up here we had 4, then 3, then 2, then 1, then 0. Sometimes they skip those place values. Okay, just like if we said we had a number like that. All right, we have 6 hundreds, but we have 0 tens, and then we have 4 ones, right? So it says, of the expressions below, circle all that represent polynomials. So discuss ones that aren't polynomials. They fail the definition above. So this first one, definitely a polynomial. All my exponents are positive. And let's see, what else do we need to think about? All my exponents are positive, and it's good. We're fine. So let's look at that second one. 9x squared, good so far, plus 2x, we're still okay, plus 1 over x. Well, let's think about that from last unit. That right now has an x to the first power, but really, if I could rewrite that, and now I have x to the negative 1. So is that a positive exponent? No, it's not, so that is not a polynomial. The third one, we look at the exponents, and they're all x's, but the bases are all different. Could x be anything? X could be a half, x could be negative 5, x could be 0.25. We don't know what that x is, but we do know that there's the possibility that it's not a positive integer, so not a polynomial. And this last one, 2x squared plus 5x cubed minus x, it's like to the first power, plus 8. Yeah, all those exponents look great. It's not in standard form. Standard form would be put the highest exponent term first and then decrease from there. Okay, so now it's in standard form. Those two are equivalent, but now we've got it in standard form. So go ahead and let's flip the page. It's often important to place polynomials in standard form. Oh, look at that little foreshadowing there, and I didn't even realize it. The standard form of a polynomial is simply achieved by writing the expression where the powers of the variables always descend. Okay? That's our standard form. All right, so with this first one, pick the exponent that is the highest exponent, so to the third power, that's my highest, and then decrease exponents from there. So I've done those two terms. Now it's minus 8x plus 7. I'm just rewriting them. Let's hop over to C. Negative 5x squared has to come first. That's the highest exponent. Then minus 2x plus 3. Okay. Polynomials are simply abstract, okay, representations of numbers, okay, that we see every day. So they behave like these numbers as well. So I did mention that in the beginning, that they absolutely behave like our regular numbers do. All right, so let's go to, let's see, do I want to do a, yeah, let's do it because I don't know, I kind of like it. I think it's pretty cool. So it says consider the numbers 523 and 271. Write each as the sum of multiples of powers of 10 like we did on the first page. So I know that I have 500 plus 20 plus 3, which is 5 times 10 squared plus 2 times 10 to the first plus 3. We agree on that. Now let's do 271. So 271 is 200 plus 70 plus 1, or written with powers of 10, 2 times 10 squared plus 7 times 10 plus 1. Now part B says add these numbers by adding each individual power of 10. I'm going to see if I should move. Beautiful. I can move this whole thing over. All right. So what am I going to do? I'm going to add up my powers of 10. So just like any adding, I've got to line up place values. So my first one, doing a little vertical addition here, okay, like it did back in elementary school. It just looks a little funky, but this is what you were doing, okay? All right, so what do we end up with? So we end up with 7 powers of 10 plus 9, or excuse me, 7 powers of 10 to the second power, okay, or 7 hundredths, plus, now we have 9 10 to the first, right, or 90, plus 4. So how does this translate into a number? We have 794. Okay, and you would agree with me that 523 plus 271 is 794. Again, what's the purpose? It's to now draw the parallel to polynomials. So what do we have here? We have 7x squareds plus 9x's plus 4's, or plus 4. Okay? Find the sum of the polynomial, and I did write over that one. All right, so now they just didn't write it vertically, but it's just combining like terms. So we end up with 3x squareds plus 4x's plus 1. Okay, so just written differently. All right, so it says finding sums of polynomials is easy. Subtracting them, though, can lead to a lot of errors. So we just got to be careful with subtraction. Find each of the following differences. So what is really happening here with subtraction, right? So we've got our first polynomial, 6x squared plus 5x plus 3 minus 2x squared minus 4x plus 7. So if I've got to subtract these two, we're subtracting, be real careful. So 6x squared minus 2x, you all know is 4x. But now it's, when I'm looking at my x's, it's 5x minus a minus 4x. Think about that. 5x minus a minus 4x is really 9x. And now, looking at the constants, 3 minus a positive 7 is 3 minus 7, which is negative 4. Okay. Little harder to see when it's written vertically. That's why I do prefer writing it horizontally when we're subtracting, because what are we doing? We're distributing a negative 1, and then we're combining like terms. That's all it is. So I tend to like to rewrite this. So plus 2x squared minus x plus 3. So I distributed that negative 1. Now just combine her like terms. So we have 6x squared minus 3x plus 10. Holy smokes, 15 minutes, and I got another lesson to do. All right. For each of the following, write an equivalent polynomial in simplest standard form. Let's go to B. I like B, okay? A, pretty simple. Let's look at this one. So we've got to distribute that negative 1. So I'm going to start my rewrite of the terms I don't need to do anything with yet. But now I'm going to distribute that negative 1 and combine my like terms. I should end up with 5x squared minus 2x minus 2. Go ahead and flip over to lesson 2, which is polynomials multiplying. Okay. So polynomials, as we saw in the last lesson, behave like integers. So adding one polynomial to another polynomial results in a third polynomial. Okay, the same will occur with multiplying them. So monomials are the simplest. Mono meaning one term. Simplest of the polynomials. They consist of, okay, one term. Terms, now they're defining terms. Terms are separated by addition or subtraction. So it says find the following products of these monomials. So when we multiply, all right, we did this with our exponents. When we multiply, you've got to multiply the coefficients, 5 times 2, which is 10. And then when you multiply, what do you do with the like bases? We add them, 10x to the 5th, okay? This is going to be a positive 24x squared. You're multiplying, add your exponents. This one's going to be 3/8 x to the 11th, okay, y to the 6th. We also use the distributive property. Okay, so we're going to now use the distributive property with our monomials and polynomials. Find each of these products. So again, let's distribute this 2x. So what is 2x times 3x? It's 6x squared. As you're multiplying, you have to remember to add those exponents. And 2x times negative 1 is negative 2x. So now the thing is that you need to be able to understand is you can multiply unlike terms. You just can't add or subtract unlike terms. They have to be like in order to add or subtract. You can multiply anything, right? So let's go ahead and 4x to the 4th plus 3x squared. All right, here's one that involves x's and y's. So negative 4x to the 3rd, y to the 4th. Okay, you might be wondering where that's coming from. Think about it. Plus 10x to the 3rd, y to the 3rd. All right, part D. A binomial times a binomial. So we've got two terms, x plus 2. X is a term and 2 is a term, times another binomial. So this is just double distributed. I think we did this in the beginning of the year. I can't remember. X times x, x squared. X times negative 6, negative 6x. Now I've got to distribute the 2. 2 times x, 2x. 2 times negative 6, negative 12. And now I can combine any like terms that I may have. Let's hop over to F. Again, two binomials times each other. So let's double distribute. 15x squared minus 3x. And now I'm going to distribute that negative 2. Negative 10x plus 2. Combine like terms. Okay. All right, never forget that as we do these manipulations, we are using properties of equality, okay, to produce equivalent expressions. So consider these two products, right? I think we're going to bypass this. Oh yeah, this is the good stuff. Exercise 4. I think I've had too much coffee today. It says find each of the following more challenging products. I love these. All right, so 2x plus 5 to the second power. What does that mean to raise something to the second power? It means to write it twice. Okay, we know what that means. Now, multiply. So now double distribute. 4x squared plus 10x. Now we'll double distribute again, okay, or distribute again, that 5 plus 10x plus 25. Combine like terms. 4x squared plus 20x plus 25. Boom, there's your answer. Okay, we just multiplied. Holy smokes, we have a binomial times a trinomial, okay, 3 terms. So with this one, you could triple distribute. I tend to like to do something like this. I give myself a little graphic organizer. It's fabulous. You absolutely do not have to use it. I just like it because it really organizes things for me and then I don't make a mistake. So I put x plus 2 here. And then I put my trinomial, x squared plus 4x plus 3 on top. And then I just find the area of all these boxes, of all these rectangles. Area is length times width. Do you agree? Okay. So what is x times x squared? It's x to the third. Now do that second box. What is x times 4x? It's 4x squared. Now find the area of this third box. X times 3 is 3x. Now go down to the bottom. What is 2 times x squared? 2x squared. Running out of colors here. What is 2 times 4x? 8x. And then finally, what is 2 times 3? 6. Now, combine like terms. X squareds are my like terms. I've got some x's. What's my final answer? In standard form, x cubed plus 6x squared plus 11x plus that little constant on the end. Checking my work because I did it fast. Yes. Winner. Okay. All right. I think we'll save the rest of these. Okay. I'm thinking. Let me just peek down below. We'll do this one for the warm-up, okay? We'll do C for the warm-up. Go ahead and try it at home, but C we'll do for a warm-up in class. Nice job, guys.